All right, we are live and let's start off with the class. So, Bismillahir Rahmanir Rahim. Today we are going to be covering the second part of our very first topic, data representation. We are basically going to be studying how do we convert denary numbers, denary into binary. We yesterday studied how we convert binary numbers into denary numbers. Like we discussed it using this example that there is a formula where you get value is equal to base raised to power. And then we have values for each specific position. And using that, we find basically the specific binary, we convert the binary value into a denary value. But today we are basically going to be studying that. Let's say if I give 20 a number to, let's say, Saifullah, and I ask Saifullah to convert this into a system which the computer can understand. So how will he be doing that? This is basically the concept we will be covering today, which is basically conversion of a denary number into binary numbers. Now there are two methods to this. The first method is pretty easy. Let me write it up here. The first method, it's pretty easy, pretty chill, pretty cool, and I personally will recommend this. There is another method which you can go with, but I personally would not be recommending it. So the first method, it's like really cool. Let's say I have the number 30, 30. Okay. Now I want to plot 30 into a binary number system. Now, if you remember, how did we get a denary number system from a binary value? If you remember, we just added up the values, right? Where we had a 1. So like for this example, we did 1 was here. The value for this 7th position was 128. Then for this, it was 16. Then for this, it was 2. So 128 plus 16 plus 2, 146 was our answer, right? So the same could be applied up here. Why not just write the values up here, starting from 1, 2, 4, 8, 16, 32, 64, and 128. Do you guys know how we found this value? We got these values from the formula which we discussed yesterday, which was basically value is equal to, perhaps it was something up here, value V is equal to base raised to power position, right? So using that formula, we basically found the values for each of the positions. Now, if you remember what we did yesterday, we just added the values where we had 1 and we ignored all the zeros. Now, if I want to find 30, okay, I need to find 30. I need to just put 1 at the slots where I add the value of the corresponding values. I should be getting 30. Now, where should I be keeping the first one? If in this example, move from the most left side. Should I be keeping 128 on? No. Why? Because 128 is way larger than 30. So it should be a 0. 64 on? No. It should be again a 0. 32 on? No. It's 30. Again 0. 16 on? Yes, 16 should be on. 16 plus what should be giving us a 30? So now we need to play with the remaining 4 digits. 16 plus 8 is 4, 4. It's 28, right? So 16 plus 8 is, 16 plus 8 is 24. 24 plus 4 is 28. And finally, 28 plus 2 is 30. Do we need to include 1? No, not at all. It should be a 0. So we get the binary value as 0, 0, 0, 1, 1, 1, 1, 0. So that's basically a very simple example of how I converted a denary number, which is this. This is basically your denary number into a binary number. So a denary into binary. Now let's say I want to confirm whether this is correct or not. I have this as a binary number now, right? See, this is a binary, which is a base 2 number system. How did I get to know that this is a base 2 number system? Basically, I only have zeros and ones. Because we only have zeros and ones, we are just dealing with binary values. If I had something like a 2, 3, 4, 5, 6, 7, 8, 9, then it would have been a denary number system, base 10 number system. But as I only have a base 2 number system, it is called a binary number system. Now, let's say I want to convert this back into the same number. How am I going to do that? Firstly, find the value for each corresponding position. How do we find the value? Value is equal to base raised to power the position. So the same formula which we discussed yesterday. This is basically position number 0. Then this is 1, 2, 3, 4, 5, 6, 7. We discussed that the first position for a computer is always going to be a 0. We are going to be starting from 0 always in computers. So 2 raised to power 0 is 1. 2 raised to power 2 is 2. Then 4. Then 8. 2 raised to power 4 is 16. 2 raised to power 5. Yeah, it's 30. Exactly, it's 30. 16, 32, 64, 128. Now, if you just add up 16 plus 8 plus 4 plus 2, it's going to be 16 plus 8 is 24. 24 plus 4 is, let me just write it, 16 plus 8 plus 4 plus 2. 16 plus 8 is 24. 24 plus 6 is basically 30. So we just firstly converted denary number 30 into a binary value. You see, binary. What I did, I just wrote down the values, and then after that, I just placed a 1 where I wanted to place a 1 at those specific slots where when I add the corresponding values, it should be giving me a 30. So I first found the binary value up here. You see, like up here. This is your binary value. This specific section. This is the binary value. How did I find it? I just wrote the values above. This is something which you should memorize. 1, 2, 4, 8, 16, 32, 64, 128. How did I get to know? I just multiplied. The first one is going to be 1, then it's 2, multiply by 2, multiply by 2, multiply by 2, multiply by 2, and this just continues. There is no limit to it. There is not a stop at 128. If I want some extra 1 up here, then it will be 128 into 256. So 1 up here will be having a value of 256. Okay. So, but in your example, it's usually an 8 bits register. So in your exam, the examiner is basically going to be telling you that there is an 8-bit register. 8-bit register. So when the examiner says 8-bit register, the examiner basically means that you will be having a register is basically a slot. Let's say you have a shelf in your home where you want to keep books. Now, a 8-bit register, a register is a type of shelf, a horizontal type of shelf, just like this, and it will be having 8 sections in it. 1, 2, 3, 4, 5, 6, 7, and then 8. So you see, we have 8 smaller boxes, and each box will be having a specific value, which will be found using the same formula which we discussed yesterday. So the first box will be having value 1, 2, 4, 8, 16, 32, 64, 128, and so on. So let's discuss another example. Let's say I want to convert 48. Okay, I want to convert 48, which is basically a base 10 number system. Base 10 system. How do I know it's a base 10 number system? Because it has values. The first digit has something between 0 to 9, and the second digit also has something from 0 to 9. Also in the exam, you won't be asked to judge whether it's a denary number or a binary number. The examiner will clearly mention it that you have a denary number system 48 or the base 10 number 48. But you should just know that the conventional numbers which we are dealing with in our day-to-day life, that is usually denary number system. Okay, so now let's say I want to convert 48 into binary. How am I going to do that? Firstly, I want to write the values. So the values are 1, 2, 4, 8, 16, 32, 64, and finally 128. Now, if we are whenever we are dealing register computationally, what do you mean by register computationally? Can you clarify your question a bit? Is it like a general question or related to the topic? Can you just clarify the question, Ijaz? Okay, so let's say 1, 2, 4, 8, 16, 32, 64, 128. Okay, we have these 8 bits. Each of this specific number, when I say it's an 8-bit register, so let's make 8 blocks. Usually a register will be represented like a block, okay? Some rectangular block. It will have 1 up here, then up here, then up here. And in every small box, we will be either putting a 1 or a 0. Now we need to put 1 or a 0 in it. So 48, how am I going to be converting a base 10 number system into a base 2 binary number system? I will be putting ones only in those boxes where when I add up the value, it should be giving me a 48. What's the simplest way to it? Let's start from the most left side. So steps, I will be mentioning the steps. Okay. Yes, about that CPU synchronization and all that. That is something which we will be discussing in chapter number 4. That is software, operating software. In that, we will be discussing the whole topic in very much great detail about time synchronization, how does multitasking happen. So that will be all discussed in chapter 4. So if you don't mention that, you don't have to mention anything of that sort in your examination. The question will be clear cut. Like, let's say I will be showing you some example questions after this. The question will be straight up, you have the denary value 48, convert 48 into binary, and then you will be having this like a slot like answer, and then a single line where you need to be just writing the answer. Now let's just find out what's the answer will be, what's the answer going to be, and then let's write it up here. So 48. How am I going to convert it? Multiply by 2. No, you won't be multiplying it by 2. Multiply by 2 is basically when I want to find the value of the next. Now, let's say the examiner gave us a block like this. It's an 8-bit register, okay? We already know the values. The first value is 1, 2, 4, 8, 16, 32, 64, 120. If you want to find the values, let's say the examiner won't give you the value. That is something you need to memorize, okay? But let's say you want to find the values, we will be having, it will be like 1. Then if I want to find the value for the second one, multiply by 2, 2, multiply by 2, 4, multiply by 2, 8, multiply by 2, 16, multiply by 2, 32, multiply by 2, 64, multiply by 2, 128. So this is basically how you are going to be multiplying so that you can find the value for each small box. Now I'm only going to be putting ones or turning on the specific boxes where when I add up the corresponding value, it should be giving me a 48. Now steps. Let me just erase it. These steps are really cool. Okay. The first step, always check from right to left. Okay. Right to left. If you remember yesterday, I said left to right. This time you need to check from right to left. It's just right to left because we need to ignore the values where when we turn it on, it should be greater than 48. So ignore values greater than greater than greater than 48. Exactly, Osaim, right? That's how we pronounce your name, right? So 128 is greater than 48, ignore 0. 64 is greater than 48, ignore 0. 32 is greater than 48, no. Let's turn it on, 1. So 32 plus what thing will give me 48? This is where I was mentioning yesterday that you won't be having calculators, so your mental math should be a bit good. You can do basic subtraction. 48 minus 32, it's going to be 6. 4 minus 3 is 1. So just have a look. Do we have a 16, a box having a corresponding value of 16? Yes, we do. We do. It's a pair 1. So once we get it, this means we got the answer 48 by turning on these two ones. So let's ignore all the other values. So it's going to be 0, 0, 0, 0. So you get the answer as 0, 0, 1, 1, 0, 0, 0, 0. So this is basically how you convert a denary number system into a binary number system. Exactly, we are going to be turning on 32 and 16 for 48. Exactly. Now let me see. Let me give you all a quick example. I want you guys to convert 15. No, perhaps not 15. Perhaps 15 will be very easy. Convert 18 for me. Give me the answer in the chat box. Until then, I will try to find some question. Convert into binary. Just write up your answers and don't share it right now. Okay, someone did. Okay, so exactly, yes, we will add up all the values. We are just going to be putting 1 at those specific slots. Like, see, what did I do up here? I wanted to find 48. So I know the values for the each smaller box. Okay, I just made 8 blocks and I know the value for each block. Now I'm going to be putting 1 only at that place where when I put 1 and I add the value, like you see, I put 1 and I'm adding 16. Then I put 1 and I'm adding 32. So 32 plus 16 is what? 32 plus 16 is basically a 48. So I'm just going to be putting 1 at those slots where when I put 1 in it and I add the corresponding value, I get the number which I want to convert at the start, which is 48. So convert 18 into binary. Let me quickly find some example question for you all from the official exam paper. Let's open up the most latest paper, summer 24, QP12. Let's see, do we have a question up here? Okay, such a good question, guys. We directly got a question on the same topic which we are studying. Let me just copy it up for you. How do I take a screenshot? Yeah, you take a screenshot like this, and then you do it like this. It's saved. And I learned this because yesterday I didn't get how do we do that. But just a moment. Yep, I need to add a picture up. Wait, perhaps not up here. Let me add it up here. Just a moment. Let me create a new page for you so that we have much larger space, and then let's do it. So current template, and let's add up the question up here from files. Where's the screenshot? It's up here. Okay, open. Let me rescale it. Can you guys see the question? Okay. Let's first solve the question which I asked you all earlier. Convert 18 into binary. What do you have to do? Write the values first: 1, 2, 4, 8, 16, 32, 64, 128. Ignore all the values which are greater. Come to 16, 1, 8. What do I need to add into 16 so that I get an 18? I just want to add a 2 into it. So ignore all the other zeros in it. So you get the answer as 0001010. Perfect, 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 perfect. Usam got it correct. Hassam got it correct. Muhammad Ahmed got it correct. Um, Ma'am Sadia's son got it correct. Ma'am Sadia is a very goated teacher. She is a counselor too, and so her son is studying. Good to see you here. And Ijaz got it correct. Perfect, perfect, perfect. If you didn't get it, no worries. Momina got it correct. You just need to do it like this. You write the values 1, 2, 4, 8, 16, 32, 64, 128, and then you only put ones at those slots where when you added the corresponding value, I added up 16 and then I added up 2. 16 plus 2 is 18. So I got the answer 18. Now, you will be getting an exam question like this. Okay. What's the question? Three ternary numbers are entered into a computer. The computer converts the numbers and stores them as binary. Now, they clearly mention that it's a denary number. Okay. Yeah, you have to see it. Like, see, if I'm dealing with converting a 15, why will I be adding 64? Like 64 plus what will give me 10? Nothing, right? I need to add something which is smaller. Smaller plus something will give me 10, right? Something smaller than 10. Is it possible if I add 100 plus something can give me a 10? No, it's not possible because we don't have negative numbers right now. We only are dealing with positive numbers. So if I want to get a positive answer, I need to make sure that the digits which I'm adding are smaller than the final answer I need. So like, look, the question clearly mentions three denary numbers. Remember, I said you need to work with denary numbers. If the examiner wants to tell you about some other number system, they will clearly mention. So three denary numbers are entered in a computer. The computer converts the number and stores them as binary. Give the binary number that would be stored for each of the denary numbers. Okay, we got the question. It's free 3 marks. Free marks. Free marks. Okay, we just need to convert these three numbers. But important thing, important. Do show working. Usually what happens is you miss the working and you lose marks. Now at this stage, you have three basically different questions. You will be getting 1 mark for this, then you will be getting one for this, and then you will be getting one for this. But let's say you miss it and it's like a 3 marker for just 201, and you just directly write up the answer. They are going to be only awarding you 1 mark. Now let's solve it together, guys. Let's solve it together. Now, okay, Ijaz, you said 64 minus 46 is equal to 18. I do get that. But tell me one thing. Is there any negative value in this 8 digits column as of now? Do you see any minus 46 in this? You don't have negative numbers right now. That's the main concern. We don't have any negative values. We only have positive thingies. When we have negative numbers, yeah, there can be a possibility which we will be discussing later on. But right now, we are only discussing the positive thingy. So exactly. That's a two's complementary. That will be something which we'll be discussing later on. No need to confuse. Right now, just see we have positive numbers. No need to be sorry. I really appreciate the fact that you guys ask such questions and you share your opinion. This is telling me that you guys are exploring computer science. And if you are someone who doesn't ask question, then do know that you are not someone which I might be thinking that you are a very smart person. If you are someone who even asks the wrong question but is asking questions frequently, you are someone really close to me, because I love students who ask questions. You should ask as many questions as you can, because the more you ask, the better your concepts are going to be, and the more the chance for scoring that distinction or an A star in your examination. Because aim for as big thing as possible. Baki jo hota hai naseeb, but you should aim for big things. Okay. So now let's do 10. Kaise karna hai? Just write up the values. Let's say I write up values up here: 1, 2, 4, 8, 16, 32, 64, 128. Then I'm just going to be writing 10. Okay, matlab 10 wale mein yahan pe karunga. Then 51 is going to go like up here, and 201 is going to go up here, right? So now let's do it for 10. Okay, a lot of you did answer that really good, but just a moment. So 10, how am I going to be doing that? Just turn and put ones at slots where I want to get the final answer as 10. So is 128 greater than 10? Yes, ignore. ignore. Finally coming to 8. Is it greater than 10? No, it's so let's turn this on. 8. So 8 plus what number will be giving me a 10? 8 plus 2 will be giving me a 10, right? 8 plus 2. So 8 plus 2 will be giving me a 10, and I finally get the 10 answer. I will be ignoring the other values. 0 plus 0. So this is our answer. I'm just going to be writing this up here. 0 0 0 0 1 0 1 0. You get a mark. 50. Again, let's do it. 0 0. Why am I putting a 0? Because the values are greater than 50. Ignore them. 32. Yes. 32 plus what thing is going to give me a 50? 32 plus 16 is what? 32 plus 16 is 48, right? So I'm going to be putting 1 up here. 48 plus what thing will be giving me a 50? 48 plus 2 will be giving me a 50. So 1 at the 2 slot and 0 at the other slot. So we get the answer as 00 11 00 10. Finally 201. So 128 on. Okay. Now you need to do maths. 128 plus 64. What's the answer going to be? 8 plus 4 is 2 with 1 carry, right? 3. 6 plus 3 is 9. So 192. 192. Now 201. What do I need to add in 192 so that I get the answer 201? We need to write we need to do 9, right? Plus 9, exactly, Usain. Plus 9. How am I going to be doing? Yes, Saifullah. 8 plus 1, perfect. So ignore 32. Why? Because we need to just add 9. Ignore 16. Now 8, yes, less than 9, right? So 1 up here. And what do I need to add in 8 so that I could get a cumulative 9? It's going to be 1. So ignore the other 2. You get the answer as 11001001. That's it. Free 3 marks. Free 3 marks. This is just part B. You have a part C of a similar stance and a part A. So you easily get around 10 marks out of 75 from this chapter. It's such an easy chapter. You just have to do these calculations. Now, you all should just let me know. 11001001. Perfect. Exactly. No, not double one. It's single one. You added an extra one. Just have a look. It's 1 is going to be 0. Yeah. So this is basically conversion from binary to denary and denary to binary. Is it clear till this very moment? Let me know in the chat box, guys. Quick. Let me know. Perfect. Great. If you have any questions, just let me know, guys. I'm here to help you all. This is the purpose of these classes. You need to understand every single thing, even if there is a small doubt in your mind. Yeah, the first chapter is easy, and I'm telling you, it's the most boring topic. I personally hate this topic. It's really easy, but it's really boring. And the topics after this are just going to be more cool because we are going to be connecting each of the topic to our day-to-day life. So it's going to be very, very fun. So going back, what's next? Okay. So to this, till this very moment, we basically discussed, let me get a new page. Let me write it up. So what did we discuss till now? We did base 2, which is basically binary. No, it's really easy. I'm telling you, inshallah, the whole chapter is easy. The whole syllabus is easy. So we are done with binary. Tick. We are done with denary, base 10, which is basically denary. We are done with denary. Now, we have a third number system in our computers. A third number system, which is basically base 16 number system. And that is known as hexadecimal. Hexadecimal. Now, how is hexadecimal different from binary and denary? Now, we studied that binary is a base 2 number system, which means that it can only have 2 possible values, right? It could be either a 1 or it could be a 0. Now, then after that, no worries, guys. I know you all are studying. Even if you're not studying for the first time, I will be explaining every concept in a manner because I want you all to understand it from the basics. It's really important that you guys understand the logic behind every step. Usually, you just go ask them random student, why is binary called a base 2 number system? They won't even know the answer. The reason behind this is because it has only 2 possible options. It could be either 1 or it could be 0. Then a base 10 number system, which is basically denary. Why is it a base 10 number system? Because you can have values from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you add 0 to 9, it's basically 10. And now we finally have a hexadecimal, which is a base 16 number system. Now, how is it a base 16 number system? Basically, we have the 0 to 9 from the denary, just like denary. Okay. And then after that, as I mentioned, if you remember, I told you that whenever we are talking about computers, we are always going to be discussing single digits. So like, why don't we have a 10? Like, why don't we have a 10? Because 10 cannot come under a single digit. It always has to be in, it always has to come in 10 digits, sorry, 2 digits, right? It's going to be one and zero in the other. Now, to solve this issue, computer programmers came up with a number system known as hexadecimal number system. Now, the hexadecimal number system goes from 0 to 9, and then after 0 to 9, they wanted to include 10 to 15. Okay, they wanted 10 to 15, but you can't include 10, 11, 12, 13, 14, 15 in a single slot, right? Because a single slot is reserved for a single number. Now, what did they do? They introduced characters for it. And by characters, I mean they introduce A to F. What do I mean by A to F? Just you should be focused about this. Now, A basically is a code for 10. Okay. B is a code for 11. C, क्यों करा यार है भाई? यार ये है, computer is something which won't get the easy language, guys. देखो, there is a reason why computer scientists and the people who study computer have such a high aura, man. I'm telling you, when you study programming and all that at a high school level, and when you tell someone, oh man, I can do programming, आपके जो level है ना, next level, you're just someone next level. So I'm telling you, you are learning something which 90% of the other people cannot even understand. You're learning the language of computers, guys. Should be just feeling very proud of yourself. Congratulations, you are doing something very unique. I'm proud of you. And then C is 12, D is 13, so 13, A, B, C, D, E is 14, and finally F is 15. Now, why did we introduce these characters? बिल्कुल guys, I'm telling you, once you learn programming, the flex level thing भी बहुत next level हो जाएगा, inshallah. So why did we introduce the characters A, B, C, D, E, F rather than writing directly 11, 10, 12, 13, 14? The reason is because computers can only understand single digits, 0 to 9, single. But it cannot get 12, 13 because these are not under a single digit. A 12 will be 2 digits, 1 and 2. So it's really good we have someone, a unique piece who is taking computer science, and this is really, really good. Now, coming to the main thing, hexadecimal number system. When I say something like 7B, 7B will basically be meaning a 7 denary, like the first digit is having the value 7 and the second B is basically having the value 11. Now, the way, just like before, we discussed conversion from binary to denary, denary to binary. Now we are 100% Ijaz, perfect. It's not about flex, it's about solving the real life problem. I'm telling you, once you understand computer science and you learn programming, many people use these programming skills to even solve their day-to-day problem. Like a person just developed a water drinking reminder for himself. So it's for your own ease, okay? It's not like for maybe a career or something. It's something really cool which you can incorporate into whatever field you're trying to go. So computer science is a really cool thing. Now, first thing, we need to understand converting binary into hex, into hexadecimal. Hexadecimal. So if I want to convert a binary number into hexadecimal, there is a specific method to it, okay? The specific method which we will be using is basically, let's say I have a value 11001010. Now what is this? This is a binary number, okay? This is a binary. Now I want to convert this into a hexadecimal number system, into a hex. Now when I want to convert it into hexadecimal number system, the process is firstly steps. Let's write the steps so that if you are reviewing the notes later on, you should understand what I'm trying to do. Steps. Number one, break this number, break the binary number into sets of 4, into sets of 4 digits. And we studied it yesterday, if you remember, that 4 bits is basically called a nibble. Nibble. What is a nibble? Nibble is 4 bits. 4 bits or 4 digits. For computer, it's not a digit. Computer counts it as a bit. Now I have this number. I need to break the number into groups of 4 digits. Where can I break the number? I can see it if I move from the most left side or from the right side, no difference at all. But let's say I want to break the number in between. So 1, 2, 3, 4, break the number. 1, 2, 3, 4. Okay, perfect. Now we have these two groups. We have a group of 1100, and then we have a group of 1010. Now I'm going to be finding the value separately for each of the group. So what's the value for this first position? It's 1, 2, 4, 8. And now this won't be going like 16, 32, 64, 1. It's now a separate group. So again, 1, 2, 4, 8. Now tell me the value for the first group. It's going to be 8 plus 2. It's 10. What's the value for this? No. uh, देखो इट वॉन्ट बी जीरो. देखो जीरो इसलिए नहीं होगा क्योंकि आपको वही वैल्यू होगी ना 1 2 4 8. यू नेवर हैव जीरोस. आप ऊपर जाओ, जितने हमने यहाँ पे ऊपर देखो these values which we found, the first value is always 2 raised to power 0 is 1. So the zeroth position will be having the value 1 and the first position is going to be having the value 2. So ये scene होगी. So now going back down to the same thing. So we have 10 up here, right? And then we have 8 plus 4, 12. But the problem is you can't write the answers in 2 digits. We need to convert it into the code which we mentioned earlier. A is 10, B is 11, C is 12, D is 13, E is 14, and finally F is 15. So now, what is 12? 12 is a C, right? So I'm going to be writing it as a C. And then what's 10A? 10 is basically A. So your final answer is CA. Exactly. समझ आ रही है guys? Let's do another example. Something just may we have digits too. So let's say I have a number 0010 and then I have a number 1011. Okay? Yes, okay, I'm explaining. The first step, break the binary number into sets. Oh man, Control Z. Into sets of 4 digits. I need to break the whole number system into equal sets of 4 digits. Now, a 4-digit set is basically called a nibble. Why is it called a nibble? Nibble basically means a data which has only 4 bits. 4 bits means 4 digits. So 1011, this is one nibble. Okay, this is one nibble. And then if I do it like this, 0010, this is another nibble. So we have 2 nibbles right now. This is one group, this is the second group. Okay, now we have these 2 groups, right? Now I want you all to understand that first we are going to be breaking it. So हमने 4 के groups में break कर दिए. We broke the group in between. किस तरह में पता लगा? This is fine because we have 4 at the left side, 1 2 3 4, and then we have 4 on the right side, 1 2 3 4. So now we are going to be dealing with each of the groups separately. So the first one is going to be 0010. This is a separate group, and then we have a 1011. Now whatever connection they had, break the connection. There is no more connection. No more connection. No more connection. So you don't have any connection between the 2 values anymore. It's 0010 and 1011. Both of them are separate. Now, find the specific Denary value. Okay. Number 2, find Denary value for each group. Find Denary value for each group. So now we need to find the Denary value for each of the group separately. Now, how am I going to be finding that? Again, 1 2 4 8. The same values जो कि हमें पहले मिली थी base raised to power position. Now it's binary, right? So for the first one, it's going to be 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. So it's 1 2 4 8. And similarly 1 2 4 8. Now what's the Denary value for the most left side group? This group will be having a Denary value of 2. Okay, and this one is going to be having it 8 plus 2 is 10 and 10 plus 11 is 8. So it's going to be like 8 plus 2 plus 1. 8 plus 2 is 10, 10 plus 1 is 11. So we have 2 and 11. Now I can write 2. Why can I write 2? Because it's a single digit. It's a single digit. Computer can write it as a single digit, and also we can write it as a single digit because you see we talked above that a hexadecimal can include numbers from 0 to 9, which are basically single digits. And if you get a value greater than single digits, where we have it till like 10 11, yes, the class is till 5:30. Why we have not taken 4? Where did we not take 4? We didn't take 4 because you see we broke the group, right? So we have 0010. Now the 1 is turned on at a slot where we have the value 2. It's not No, basically, when you break a big group, a big binary group into sets of four digits. And you see, I broke this big binary number, which was of 8 bits initially. It was 1, 2, 3, 4, 5, 6, 7, 8. It was 8 bits, but I broke this into groups of four. I had a group of four, 1, 2, 3, 4, and then I had a second group, which was 1, 2, 3, 4. I broke it into groups because when you are dealing with hexadecimal, okay. So why did I break it into groups? Good question. I broke it into the group because hexadecimal basically operates on small nibbles. Okay, when you're dealing with hexadecimal values, understand that we are dealing with nibbles. Okay, so whenever you see the term hexadecimal, you are always going to be, this is like a step to solving it. You are always going to be breaking it, because if you don't break it into nibbles, what's the difference between binary and denary? Like, let's say I remove this specific breakage column and I just do 1, 2, 4, 8, 16, 32, 64, 1, then it's basically conversion from binary into denary. But we are not converting from binary to denary, we are doing it binary to hexadecimal. So when I want to convert it from binary to hexadecimal, the first step is that you need to understand that hexadecimal will be operating on nibbles. Nibbles basically means group of 4 bits. And so I will be breaking a large value into groups of 4. So I broke the group in here, and now I have one group which has 4 elements in it, and then I have a second group which has elements of 4. So a binary number, which is a hexadecimal number, which is basically a base 16 number system, will always operate on nibbles, which means that we will be firstly breaking a large number into groups of 4, and then using each of that group of 4, we are going to be finding the specific hexadecimal value. Now let's go back. We have a 2 up here, right? We can directly write 2. Why do we write 2? Oh, no, no, no. Yes, I am teaching how do you convert into hexadecimal. We just discussed how in the start, how do you convert binary to denary, denary to binary first, and then we studied denary to binary. Yeah, we studied denary to binary. Okay, okay. Okay, so we have 2, okay, and it's a single digit. Okay, so we just write 2, and then up here we have an 11. Now 11 is a double digit value. Okay, double digit. So when we have a double digit value, we can't write 211. It will be wrong, because we can only write a single digit. Now what am I going to do? I'm just going to go up to the same key which I wrote up here: A, B, C, D, D, E, F, and the corresponding value. Now B has the value 11, right? So I'm going to be writing a B up here. So you get the answer as 2B. So this is your answer, 2B. Clear cut. Okay, okay, guys, chill, 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 chill. We do have a lot of kids who have not studied this, so no worries. आप लोगों ने पढ़ा है, good for you. But just listen to all the class clearly, because हम सब कुछ फिर से with logic पढ़ रहे, so it's really good कि आपको समझ आए. Now, is this clear? We will not write 4. No, where are you trying to say? Where do we have to write 4? आपकी क्वेश्चन ही मुझे समझ नहीं आ रही. देखो, आप 4 तब लिखते ना, आप तब 4 लिखते जब आपका ये वाला जो है ना, ये देखो, वेट लेट मी हाईलाइट इट, ये वाला जो है ना, ये 4, ये अगर 1 होता ना, लाइक इफ इट वुड हैव बीन समथिंग लाइक 0 1 0 0 ना, तो तब वी वुड हैव रिटन 4, क्योंकि इट वुड हैव बीन 1 2 4 8. तो ये 1 4 वाले पे है ना, तो क्योंकि जब 4 वाला 1 होता तो तब हम 4 गए. बट राइट नाउ इफ यू सी 4 के नीचे वी हैव अ 0, because it's 0, तो 1 0 1 1. So 1 0 1 1 is not 4. Just add up the values. It's 8 plus 2 plus 1. 8 plus 2 plus 1 gives us 11. It does not give us 4. See? Oh, yes, you don't have a, even if you look at this, it's 8. You have a 8, then you have a 2, then you have a 1. 8 plus 2 plus 1 is basically 11. It's not 4. And right up here, it's 1 2 4 8. We have a 2, so it's going to be 2. So is it clear till this very moment? Got it. Great. Okay, chalo. Let's move on. Now we studied how do we convert binary into hexadecimal. Now let's study the other way around. How do we converting hexadecimal into binary? Just repeat whatever we did previously. Let's say I have a number, and that number is C5. Okay, I have a number C5. Now you see, what did we do previously? We had a big number, okay, and then we broke the number into two different groups, and then each group gave us some specific value. Okay, now the same thing is going to happen up here. We have C as a different group, group 1, and then we have 5 as another group, group 2. Okay, now we need to convert C into binary, and then we also need to convert 5 into binary. Convert into binary. Now, how am I going to convert each of them into binary? Let's do it up here. Okay, so we have a C, right? What's a C? A C is a no stupid question, nothing at all. आप लोग पूछते जाओ. C is a 12, right? Okay, पूछते जाओ. We are here to help you all. Okay, C is a 12. Now I will be writing it just like before, 1248. Why 1248? Because I told you that we are only going to be dealing with nibbles. A nibble is a 4-bit group, okay, 4. So we will be having 4 digits always in nibble. So the values are always going to be 1248. It won't be greater than 1248. Ye samajhna hai, sahi hai? So 1248. Now, and we are just going to be putting ones at the place where I wanted to get the final answer as 12. So it's going to be a 1 up here, then a 1 up here. 8 plus 4 is 12, so the others are going to be 0. Then we have a 5. 5 ke liye again 1, 2, 4, 8. I'm just going to be putting ones so that I get the final answer as 5. 0, 4 plus 1, 5. So 1 up here, and then a 1 up here, and then a 0. So now, previously, if you remember, what did we do? We broke it, right? We broke the big binary digit into two groups. Now we need to join the two groups. So it's going to be 1100 0101. 1100. Exactly. Perfect. Yes. So itni si baat hai. Straightforward question. Now, other thing. They can usually sometimes give you a bigger value. Say it can go something like C5A. What do I need to do in a scenario like this? Now we have C, then we have 5, now A. Now remember, when we have C5A, just deal with each of the characters separately. Deal each of them separately. So at the end, we just need to join the values. Okay, we just need to join the values, but it's important that we deal each of them separately. Like I'm going to be writing a C up here, then a 5 up here, and then an A up here, right? Now I'm going to kya karna hai? हर एक की corresponding binary value खुद ढूंढ लेनी है. So 1, 2, 4, 8. I know C is a 12. A 5 is going to be a 5. Okay, so it's a 5. A is basically 10. So now 1, 2, 4, 8. 1, 2, 4, 8. How do I get a 12? It's 8 plus 4. So 0, 0. Ignore the other two. 5, it's smaller than 5, 8. So it's a 0 up here. Then 4 plus 1 is going to be 5. So 1, and ignore this. And then A, 10. So 8 plus 2 is basically going to be giving me a 10. Ignore the other two. So now we have these three separately. Now just join them. 1100 0101 1010. Okay, just write them together. I just left this place, but it's together. 1100. Yes, exactly. Now let's say they give you a question like this where you have such large values like 1100 0101 1010, and maybe let's add up something else, 0011. Now you don't need to get scared. Remember, you just need to do the same thing which I taught you earlier. Make groups of 4. Okay, make groups of 4. So how do I make a group for 4? 1, 2, 3, 4. Okay, barrier. 1, 2, 3, 4. Okay, barrier. 1, 2, 3, 4. Barrier. Now deal with each of them separately. This is 1, 2, 4, 8. It's what? 2 plus 1, it's 3. 1, 2, 4, 8. What's 8 plus 2? 10. A. We cannot. So, no, 4 groups. See, this depends. If you want to aim for a distinction, the thing is that it's not necessary that you should be scoring full. But you just need to score the highest in the country. So like, let's say if I scored, maybe I don't know how much I scored, to be honest. I should be asking this, but let's say I got 73 on 75. No one got higher than me. So I got a distinction. But if the paper is easy, then yes, definitely you should be scoring 75. And also know that if we have multiple kids who scored full, all of them will be getting a distinction. It's not like कि आपके किस तरीके से attempt किया उस पे होता है. Teachers do say that your attempting style should be different. No, it should not be different at all. You just need to be scoring full marks, and your answers need to be just like as that which the marking scheme has. Okay, so what's up here? 8 plus 2, it's 10. Now you can't write 10, remember. Why? Because it's a double digit. Now we are again going to go to the same chart. A equals to 10, B equals to 11, C equals to 12, D equals to 13, and it goes till your F value, which is 50. So 10 is basically an A. So we are going to be writing up A. Then it's 1, 2, 4, 8. We have a 5 up here. And then finally 1, 2, 4, 8. A 12. A 12 is a C. You get your final answer as C, 5, A, 3. Exactly. Okay. The thing is, if you are appearing in October-November examination, you don't have distinctions in October, November. Yeah, I know it hurts and it's a bit bad. Basically, in Pakistan, if you're from appearing from Pakistan में October, November में there are limited number of students appearing, so they do not give a distinction. Basically, what happened was when I went for the distinction ceremony, there was a kid who was like sitting next to me, and he was like, he also got a distinction alongside me, but he was saying that he gave his ad math exam in October, November series, and he ended up getting full marks in it. But like, getting full marks means top in the world distinction, but he couldn't get it because he just appeared in October, November. So even if you are still appearing in October, November, it's not required कि आपने CS में लेनी है. Aim for a distinction in all the subjects, just maybe आती है. And for now, just try to score full for your personal satisfaction. अपने लिए बोलो कि यार, I got a distinction. Okay, so this is basically how you convert a binary number into hexadecimal number system, and also a hexadecimal number system into binary number system. So yes, aram se 3 months are more than enough to ace your entire examination. As it जैसे आप लोगों ने करना चाहिए, if you want to go with May June, go with May June. If you want to do it with the October November series, you can go with the October November series. One benefit of doing it in October November is that if you want to take an extra subject, you can go with that. And if you don't want to take an extra subject, another option is that you will be having 4 subjects, so the pressure would be less. But either way, if you're appearing from school, I will suggest that you ये course जरूर लें. Till the November one, at least for the November one, because you have your mock examinations in your December, so you will be in a very, very, very well managed preparation, so you will be easily able to ace your examinations. Usually schools do have their mock exams in December, so Sarah, you will be fully prepared. Okay. Yeah, okay, the 15 marker, it has a pattern to it. Don't worry. We will come to that later on. It's a both mazika pattern. You're going to ace those exams. No worries. Now, one final thing. Then we are going to be ending the class. Hexadecimal to binary. Hexadecimal to binary. Now, when I used to say in the voice chats that usually books or other teachers, they share some confusing methods. This was what I was talking about. Now, there is a method to doing this, which is really, really very difficult. Okay. Now, I will be giving you a very shortcut to it. Let's say we have a hexadecimal number. I will be mentioning it as hex. Okay. Let's say I have a hexadecimal number and I want to find, also not binary, it's denary, my bad. It's denary. We covered this already. To denary. Okay. And I need to find a denary number system. Okay. Which is base 10 number system. How am I going to convert it? Easy peasy, lemon squeezy. You have a hex, convert it into a binary first. The simplest way. Convert a hexadecimal into binary and convert the binary into a denary. Likewise, when you want to go to hexadecimal, convert your denary into binary and then convert your binary into hexadecimal. Let's do an example, guys. Let's say I have A5 as a hex. Okay, I want to convert A5 firstly into binary. How am I going to do? Split the two and find it separately. So 1, 2, 4, 8 and 1, 2, 4, 8. So A is 10 basically. The chart. Always write this in your exam. Even if you know, write it, because usually kids do tend to make a mistake. Even I believe mistakes ho jati hain kafi commonly. So it's 13 and E is 14 and F is 15. It always goes from A to F, nothing more. Okay. So I need a A. A is 10. So 8 plus 2. Okay. 4, 1. It's going to be 0. And then 5, 0, 0. 1 and 0, 1. So what binary did we get? Yeah, Saifullah, it's really cool. And also you guys know Saifullah was someone who didn't want you to study CS, but it's really good. See, distinction can help you a lot with your university admissions. I won't say that. It now depends on you. Are you someone who really wants to get a distinction in computer science? If you want, go with the May June series. Like personally, if I was at your slot and I knew that I'm someone who wants to get a distinction in computer science, I personally would have dropped the October November series. मैं May June में exam दे देता. Because from the day one when I started preparing, it's just for your own information. When I started preparing for my IGCSE May June 2023 Cambridge examination, I did prepare with the mindset of getting a distinction. I won't lie, from the very first day, it was there in my mind that I need to get a distinction. I need to get a distinction. And so I worked really hard. There were moments I was even at a slot at a time when I was like, A aega. But alhamdulillah, when you have it in the mind and when you ask Allah for help, you will get it, inshallah. So definitely, bilkul, 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 exactly. बिल्कुल. So now let's finalize this, and then उसके बाद if you have any questions, आप लोग उसके बाद मुझसे पूछो. No worries, I will stay for 10 to 15 minutes. No worries at all. But क्योंकि we will be sharing the recording on YouTube, so other people can also watch it. So now we have the binary, right? Just mix the two, join the two. 1010, then 0101. Now we have the binary value with us. Now, the first thing which we studied yesterday, how do we convert a binary into denary? Now, it's the normal binary base 2. Now, we don't have to work with nibbles. So the values are going to be 1, 2, 4, 8. And then, because it's a base 2 number system and we are not dealing with nibbles anymore, so 8, 16, 32, 64, and 128. Now, what do we need to add? All the ones. Where do we have the ones? We have a 1 up here. Then we have a 1 up here, then we have a 1 up here, and then a 1 up here. Just add them. 128 plus 32 plus 4 plus 1. 32 plus 4, 36. 128 plus 36. Always do it like this. 8 plus 6 is 14. Okay, so 1 up here. 3 plus 3 is 6. 164. So 164 plus 4 plus 1. It's 168 plus 1, 169. 169? Yeah, 165. Just a moment. 128. Oh, wait. Let me see. Maybe I messed it up. Calculator. Okay, guys, I can use calculator. Okay, you guys can't, but I can. Okay, it's 165. My bad. 128 plus 132. 120 plus 130. Okay. Okay, oh, my bad. This is 32. It's not 36. Okay. Yes, it's 32. I wrote it as 36. My bad. It's going to be 160. So 160 plus 4 plus 1, it's going to be a 165. Just like that, if I wanted to convert some other value, let's do that example too. Just a moment. So it's a bit more clear to everyone. If I wanted to convert a 30 into a hexadecimal, how am I going to be doing that? I will be just writing 30 into binary first. So 1, 2, 4, 8, 16, 32, 64, and 128. Convert 30. 0, 0, 0, 16. 16 plus 4, 16 plus 8 is what? It's 4, 4, 24, right? 24 plus what is 30? It's 6. So 24 plus 4 is 28 plus 2, 30, and we get this as the value. No, I did not get into an Ivy League college. Unfortunately, you have to do a lot more if you want to aim for Ivy League colleges. Okay, let me just end the recording after this. फिर मैं आप लोग के साथ में एक 5 minutes discussion वो कर लेता हूँ about the universities. So that's also really important. I will be helping you guys with your college application. Just give me 5 minutes. Let me finish this up and let me stop the recording. फिर आप लोग के साथ उस पे बात कर दो. So now, what do I need to do? Remember, you need to break it into nibbles. So 4 group 1, 4 group 2. Now deal with it separately. We have it as 1, 1, 1, 0, and we have 0, 0, 0, 1. So again, values 1, 2, 4, 8 separately for each of the nibbles. 1, 2, 4, 8. What's this? It's a 1. And what's up here? 8 for 4 is 12. 12 plus 2 is 8 plus 4 is 12, and 12 plus 2, 14. We have a 14, right? Okay, I will share the notes in the group. So 1, and what's a 14? A is 10, always write it. Remember, always write it. B is 11, C is 12, D is 13, E is 14, and F is 15. Now, this is the reason I always say, Sadullah, you see, you wrote 1D. It's not 1D, it's 1E. This is the mistake usually you can make. So 1E, E is 14, right? So 1E is your answer. That's basically how you convert binary to denary, denary to binary. This is the very, very, very goated table which you need to understand, that when you want to convert hex to binary, always go from hexadecimal to binary, binary to denary, and denary to binary, binary to hexadecimal. Always follow this, and then you will be in a very, very good state. So is it all clear, guys? Let me know. Did you guys understand and enjoy today's lesson or not? Perfect, perfect, good, 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 good. Not good, yeah. Alhamdulillah, mashallah. Chalo. Wow, Ejaz, you are from Lucky Marwat. Good to know. I'm also from Lucky Marwat. Yeah, I'm from Lucky Marwat, but I live in Aptabad. Good to know someone from my own village. Great. Um, so let me just stop the recording and then we can have a small chit chat. If you guys have any sort of questions or anything, if you guys want to leave, आप लोग जा सकते हैं. No worries. Let me just end the recording, stop presenting, and manage the recording. Just a moment. Stop recording.